Hi guys, this is A2 Chemistry, Transition Elements, and we are looking at isomerism in complexes. Question 6. In the presence of chloride ions, VH2O6 3 positive reacts to form a mixture of isomeric octahedral complexes in which we have 4 water and 2 chloride ions as shown in the equation. So complete the three-dimensional diagram to show the two isomers of VH2O 4 times Cl twice. So here we've got two chloride ions which can be either placed adjacent to each other forming a cis isomer, or they can be placed diagonally opposite to one another forming the trans isomer. So the remaining positions will be occupied by the four water molecules as stated in the equation, and in this way we have the two cis trans isomers of the given complex formed. Completing the diagram, we place both the structures in square brackets with a positive sign showing that these are complex ions. And Deva state the type of isomerism shown by isomer 1 and isomer 2. So what we have shown here is known as cis trans or geometrical isomerism. Next, the complex VH2O6 3 positive also reacts with ethane 1,2-diamine or EN to form a mixture of isomeric octahedral complexes. Now here all six water molecules have been replaced by EN. Complete the three-dimensional diagram to show the two isomers of VEN thrice 3 positive. You may use N and N in a skeletal formula to represent EN. So since we've been asked to use N and N to represent En, so that is exactly what we are going to do. And we are going to color code the En so that we can form the optical isomers easily. And here we have the second En placed. In the remaining positions, we will place the third En, thus completing the optical isomer. But the structure of the complex still remains to be completed by drawing the square bracket and placing the 3 positive sign outside of the square bracket. So here we have the two optical isomers of VEN thrice 3 positive formed. Next, state the type of isomerism shown by isomers 1 and 2. This isomerism is known as optical isomerism. Next, adding a limited amount of En to NiH2O6 positive forms the complex NiH2O twice En twice. Suggest the number of possible stereoisomers of NiH2O twice En twice. Explain your answer. You are advised to include three-dimensional diagrams in your answer. So, since we've got two monodentate and two bidentate ligands present in our complex, we will begin with drawing two of the isomers having cis and trans conformations. So these are the positions of binding of the ligands in an octahedral complex. After completing this, we will place the ligands where they are supposed to be placed. And after that, we will draw another isomer, which is an optical isomer of the cis isomer drawn. So, in order to place the ligands, we will place water molecules on opposite ends of nickel showing the trans isomer, and on two positions that are adjacent to each other showing the cis isomer. The rest of the molecule will contain two En molecules placed in the remaining positions. So this is one En molecule and this is the remaining other En molecule. So now we've got the six dative bonds occupied by the relevant ligands, and in order to complete the complex we make square brackets and place the charge of 2 positive on the square brackets to show the charge of the complex ion. So the one on the right is a trans isomer and the one on the left is a cis isomer. Now for the third isomer we would need to draw a mirror so that we can show that these are optical isomers, and we will make the mirror image of the cis isomer in this position, thereby completing the third isomer for the given complex. So these are the position of binding of the ligands as shown previously. Once completed, we are going to place the ligands in the positions where a non-superimposable mirror image of the cis isomer will form. So for water, one will be placed here and the other will be placed here, thereby mirroring the one already made. And the remaining positions will be occupied by En molecules. So one En molecule here as a mirror image of the first one and another one in the remaining position, thus completing the third isomer of the given complex. And in the text, we are going to mention that there are two geometric isomers. Let's write that down. There are two geometric isomers and an optical isomer of the cis isomer, thus making three possible isomers of the given complex. Question 7. Bubbling air through different aqueous mixtures of CoCl2, NH4Cl, and ammonia produces various complex ions with the general formula CONH3 6-N, ClN power 3-N. Determine the oxidation state of the cobalt in these complex ions. So, if we have any number of ammonia present, let's say if we take N as 1, so the overall charge would be 3 minus 1, which is 2. So the charge on the cobalt ion would be 2 plus 1, which is 3. So the charge on the cobalt ion is plus 3, or you can say that it is the CO3 positive ion of cobalt. Next, name the two types of reactions undergone by cobalt ion during the formation of these complex ions. The two types of reactions would be, the first one would be ligand substitution reactions, and cobalt has the capability of being oxidized. So it can also undergo oxidation reactions because cobalt 2 plus ion and cobalt 3 plus ion can be present in the complex. A 2 plus ion can be oxidized to a 3 plus ion. The complex CONH3 4Cl twice Positive shows isomerism. Draw three-dimensional structures of the two isomers and suggest the type of isomerism shown here. So since the monodentate ligands are in the ratio 4:2, the isomerism shown would be cis-trans. So the position of the central transition metal ion cobalt would be here. Then we would have positions of the binding of the ligands. Six ligands will bind. So we would have six positions on both the isomers represented in 3D. And once that is done, we are going to place the ligands in their appropriate positions, forming cis and trans isomers. So here we have completed the position of binding of ligands. Now, in order to place the ligands, if we have a cis isomer, we have two chloride ions on adjacent positions, and in the trans isomer, we have two chloride ions in diagonally opposite positions on the complex. The remaining four positions would be occupied by ammonia molecules. So NH3, NH3, NH3 and NH3 on isomer 1, and NH3, NH3, NH3 and NH3 on isomer 2. In order to complete the isomers, we place the square brackets and the positive sign on the outside of the square bracket. So this completes the two isomers. The type of isomerism shown is cis trans or geometric isomerism. Next, what is meant by the term coordination number? So the coordination number is the number of dative covalent bonds present in a complex. So let's put that down. It is the number of dative covalent bonds present in a complex. Complete the table by predicting appropriate coordination numbers, formulae, and charges for the complexes C, D, E, and F. So we have been given the metal ion with its charge, the ligand, the coordination number has to be put, the formula of the complex has to be made, and the charge on the complex has to be determined. So with complex C, we've got Cr3 positive ion and Cn negative ion. So Cn negative ion means it's a monodentate ligand, and Cr, so Cr, Cn. So the number of Cn has to be determined. This will be determined by the charge. So it is a 3 negative charge here. Chromium has a 3 positive charge. So 3 positive minus x equals minus 3. So x would be equal to plus 6. So plus 6 would mean that there are 6 ligands present. So CrCN6. This is the formula of the complex, and since there are 6 ligands bonded to chromium, the coordination number of this complex is 6. Next, in complex D, the charge of the ion is 2 plus, and it is a molecule which is a ligand. This molecule is En, and the coordination number is 6, which means there are 6 En molecules present. So H2N, CH2, CH2, NH2 taken thrice. Overall charge would be 2 positive because the ligands do not carry any charges. So charge on the complex is plus 2, and this completes complex D. Next, in complex E, we've got platinum 2 positive as the central transition metal ion and the monodentate ligand chloride ions, and an overall charge of 2 minus. So in order to make the formula of the complex, we've got Pt, we've got Cl, and we've got 2 negative charge. We are aware that plus 2 is the charge on the platinum ion, Minus x is a charge on the number of chloride ions present. This is equal to minus 2. So when we carry over plus 2 on the other side, it becomes minus 4. So minus x equals to minus 4. That means the value of x is plus 4, meaning there are 4 chloride ions present in this complex, which means there are 4 monodentate ligands forming 4 dative covalent bonds, making the coordination number of this complex 4. Next, we have Fe3 plus ion present as the central transition metal ion, and the ligand is oxalate because we've got two COO minus bonded together. So the number of oxalates present is 3. So in total, the charge on the complex would be plus 3 minus 3 to the 6. Plus 3 and minus 6 gives us a charge of minus 3. So the charge on the complex is minus 3. And since there are 3 bidentate ligands bonded to the Fe3 plus ion, the coordination number of this complex is 6. The cyanate ion NCO minus can act as a monodentate ligand. State what is meant by the terms monodentate. It means a species having lone pair of electrons capable of forming a single dative covalent bond. And this dative covalent bond would be with the central transition metal ion. Next, we've got the definition of a ligand. So, ligand is a molecule or an anion having lone pairs of electrons capable of forming dative covalent bonds with the transition metal ions. Next, silver ions Ag positive react with cyanate ions to form a linear complex. So, such is the formula of this complex, including its charge. So, if cyanate ion is monodentate, then Ag positive would be bonded by two cyanate ions because in a linear complex we've got two ligands in a 180-degree orientation bonded to the central transition metal ion. So the formula of the complex would be AgNCO twice, and the overall charge would be -1 because +1 and -2 forms a charge of -1. Question 8. A number of isomers with the formula CrH2O6Cl3 exist. The general formula is CrH2O 6 minus N ClN, and outside of the complex ion Cl3 minus N dot NH2O. Each isomer contains a 6 coordinated Cr3 ion in an octahedral complex. Water molecules not directly bonded with the Cr atom are held in a crystal lattice as water of crystallization. The Cr-Cl bond is not easily broken, and so chlorides bonded with the Cr3 ion in the complex do not react. 1 gram samples of 3 of the isomers A, B, and C were dissolved in separate samples of water. An excess of AgNO3 was added in each of the masses of AgCl formed was measured. Okay, so Ag positive reacts with one chloride ion forming AgCl. The number of moles of AgCl solid formed was calculated. the table shows the results. So A has a value of 3.75 10 power minus 3. B has a value of 7.50 10 power minus 3. And C has a value of 1.13 10 power minus 2. So if we equate these, the ratio of A is to B is 1 is to 2, and the ratio of A is to C is 1 is to 3. A being 1, B being 2, C being 3 in the ratios. Calculate the MR of CrH2O6 Cl thrice. So the MR would be equal to AR of chromium, which is 52, plus it would be 6 times 18 for water, and it would be 3 times 35.5 for chloride ions, giving us an MR value of 266.5. Use the data in the table above to calculate the value of N for each of the isomers A, B, and C. Complete the table below with the values of N and the molecular formula of each isomer in the style of the general formula given above. Show you're working for at least one calculation of N. So if we have 1 gram of a sample and we divide it by 266.5, we end up with a mole value of 3.75 into 10 to the power of minus 3. So 1 gram of the sample is equal to 3.75 10 to the power of 3 moles of the complex. So in this case, in 1 gram of the compound, comparing with A, we've got equal number of moles of AgCl forming. So that means that the chloride ion that is reacting with Ag positive is a single chloride ion. So that means A is equal to Cr H2O 4 times and Cl twice, because only one chloride ion is outside of the complex ion. So the number of moles of water would also be 2H2O. This is the case for A. For B, the molar ratio is 1 is to 2. That means two chloride ions would be released and react with silver ions. So the formula of the complex would be CrH2O 4 times Cl, and on the outside it would be Cl2, and it would be dot 1 H2O, because the number of N in the formula is 1. In the case of C, we have the ratio of 1 is to 3. That means 3 chloride ions are on the outside. So the formula of the complex would be CrH2O 6 times and no chloride inside, and Cl3 on the outside, and the value of N is 0, so no water of crystallization. Just to make a correction in the structure of formula B, the number of water molecules would be 5 and not 4. So that is how we would have two chloride ions on the outside. So these are the three formulae of the isomers A, B, and C based on the calculation of 1 gram of the solid converting into moles of solid and comparing the ratios of this with the isomers A, B, and C. Two isomers have the same shape and their formula is NiR3P twice Cn twice, where R is equal to CH3. Only one of these isomers has a dipole moment. Name the type of isomerism shown by NiR3P twice, CN twice. So we've got four monodentate ligands attached to the central transition metal ion forming isomers. So the type of isomerism shown would be cis trans or geometric, and the isomers that will be formed would be cis trans isomers of square planar complexes. So these are the position of binding of ligands in a square planar complex, and we have two different types of monodentate ligands present that will bind to them. So in the cis isomer, two of the same type of isomer would be positioned on the adjacent dative covalent bonds. Here we can have CN position on adjacent bonds, and in the trans isomer they will be positioned diagonally opposite to one another. And in the other remaining positions we would have R3P placed, forming the cis isomer on the left, and R3P placed diagonally opposite to one another, forming the trans isomer on the right. State which isomer has a dipole moment and explain your answer. Isomer 2 does not have a dipole moment because the dipoles cancel out, because the same type of ligands are positioned diagonally opposite to one another, which means isomer 1 will have dipole moment. And the reason for this is because they are positioned on adjacent bonds, and thus the dipoles do not cancel out. So isomer 1 here will be the one that has dipole moment, and isomer 2 will not have dipole moment as they cancel out. Question 9. 1,2-diaminoethane EN is a bidentate ligand. What is meant by the term bidentate and ligand? So bidentate means a species that can form two dative covalent bonds because they will have two lone pairs of electrons. And a ligand stands for a molecule or anion having lone pairs of electrons capable of forming dative covalent bonds with the transition metal ion. There are three isomeric complex ions with the formula CrEn twice Cl twice. Complete the three-dimensional diagram on the isomer in the boxes. You may use the skeletal formula to represent En. Okay, so we start off with making the trans isomer of this complex, in which the Cl would be placed diagonally opposite to one another, and we would have En placed on the remaining positions. Then we would convert that into the cis isomer with En placed in the remaining positions. And finally, the mirror image of the cis isomer, in which we would have Cl placed on the position that is the mirror image of the one in the center, and also the En molecules placed as mirror images of the complex ion in the center. And completing these structures, we would be making the square brackets having a +1 charge placed outside of the square bracket representing the overall charge on this complex. So this is the cis isomer, this is the trans isomer, and both of these are optical isomers of one another. Question 10. FeEd2Cl2 3 negative shows geometrical and optical isomerism. Complete the three-dimensional diagram to show the three stereo isomers of Fe, Ed twice, Cl twice, 3 negative. You may use O negative, then the skeletal formula and O negative to represent Ed. So, uh, we would have a trans isomer having chloride ions on opposite ends. Then we would have a cis isomer and a mirror image of the cis isomer having chlorides in the position that is a mirror image to the isomer B. Now the remaining positions will be occupied by the Ed molecule, which will be represented by two oxygen joined together by a line drawn this way. So here, here as a mirror image, this would be placed here, and the third one would be placed on the remaining two positions where bonds have been represented. So in this way, we have completed the three structures of this particular ion. Now, in order to complete the overall charge of the ion, we would make square brackets and a 3 negative charge placed outside of the square bracket, since this particular ion has a 3 negative charge on it. So, completing the labels, this is a cis isomer, this is a trans isomer, and these two are optical isomers of one another. Give the letters of two isomers of the complex which are geometrical isomers of each other. So here the geometrical isomers are B and C, B being the cis isomer and C being the trans isomer. Give the letters of the two isomers of the complex which show optical isomerism. A and B both are cis isomers which are optical isomers of one another. Give the letter of the isomer which has no dipole moment. An isomer with no dipole moment has the ligands placed diagonally opposite to one another, which is the trans isomer, which is isomer C.